Hey, Algebra 2. Hope you guys are doing okay this week. Hope you had a great spring break. We're going to talk today about calculating interest on an account. So we're going to talk today about compound interest. It is one of the more, I would say, maybe less frightening applications of exponents. So let's say that you have, I don't know, $500 and you're going to invest it in a savings account. And that savings account gives you 2.4% annual interest. And you want to calculate how much money you're going to have. I transposed those letters. You want to calculate how much money you're going to have after a year. So you would say, okay, well, I've got $500 to start. And after 1 year, I'll take my 2.4% interest, which is going to be, 0.024, and you'll multiply that out, and then you'll add $500. So this is how much you would earn in interest, and then you'd add $500. Another way you can think about this is you could think about it like, 500 times 1.024, right? That 1.024, that 1 represents the 100% of the account that you have, that $500, and this little bit more with interest. If you're not sure that you believe me on that, we can go off to the side and say, oh, well, you could use the inverse of the distributive property. You could factor out the greatest common factor here, 500, and what you'd get is 0.024 plus 1. So 1.024, this, if that confused you, sorry. So that's how much money you would have after 1 year. And so you could say, okay, 500 times 1.024, and what you've got is $512. Hey, not bad. You made $12 in interest. Great. Well, how much money would you have after the second year? Now you could take that 512 and multiply it by 1.024, or you could say, I'm going to take 500 and multiply it by 1.024 the first year, and then multiply it by 1.024 again the second year. And you get $524.28.8, which is weird. We probably round that up to 29, right? Well, and then after the third year, you'd have this number times 1.024, or 500 times 1.024 times 1.024 times 1.024. Do you see where this is leading? What this is leading to is repeated multiplication of 1.024 or exponents. So we could say, well, this is 500 times 1.024 to the third power. And if you have left your calculator at home, you can always go to Desmos.com. We love Desmos. Desmos.com/scientific. And they can help you out with a calculator. Now, I have my calculator here, so I'm just going to do it. 500 times 1.024, and then if you want to know how to do the exponent, see this little button? It's like a caret. We're going to take that to the third power because this is how much money we're going to have after the third year, and we get $536.87. Now, if we think about this, we're getting a little bit more money each time. We're compounding our interest. Our money is making money, right? We make money on the interest as well as the principal, that original $500. So you can see why this is a little more fun than, say, like epidemiology. So here's your challenge. I want you to find out how much money would we have after 10 years. Now let's say we're still starting with $500 as our principal, our initial amount, and we're having 2.4% interest, which translates to 0.024 being added on. So I want you to take a minute, pause the video, and figure out how much money you have after 10 years. All right. If you're back, that means you have attempted this and you want to see if you have the correct answer. Let's see. The way we would set this up is the amount we have after 10 years would be 500 times 1.024. 0.024 represents our rate. That 1 tells us that we're growing, we're getting bigger, more money. And we're going to take that to the 10th power, representing 10 years. We go to our calculator, either our calculator that we have on hand or Desmos, and we write 500 times 1.024 to the 10th power. And we get $633.83. I'm going to round up that 2.5 to 3. All right, there you have it. I've got another video coming at you in a minute.